So good morning all. I welcome you all to this lecture series of Electric Circuit and Electron Device course of first year Computer Science and Design. So in this first unit DC circuits, we are going to discuss about the topic called Ohm's Law, which is the basic of all the electronic circuits to find the value of voltage, current and resistance, which one is unknown in the given circuit. So this Ohm's law plays a vital role in circuit analysis. So let's move on to the first slide. So here, we study all the topics of the basic electronics through a design thinking approach. So I have listed the 5 stages of design thinking along with the topic of Ohm's law. So first we will discuss what is Ohm's law. So this is defined as the product of current and resistance is equal to the voltage in the circuit. So it is given in the equation form as V equal to IR, where V represent the voltage, I represent the current and R represent the resistance which is present in the circuit. So I summarize or go through the 5 stages of design thinking over here. First stage is empathy. So where the user has to understand the needs of the customer. Second stage is define, where we have to clearly define what the problem or what is the need of the customer is. Third stage is identify. So we have to brainstorm and clearly define or create the various ways in which the problem can be approached or solved. And the fourth stage is prototype. So we have to create a prototype model from the ideas what we have brainstormed and which also align with the need of the customer. The last stage of the design thinking is testing phase, where we have to evaluate the prototype what we have developed and we have to present or refine the solution according to the need of the customer. So here this diagram looks fun when you are learning this Ohm's law, where it defines a resistor or the work of a resistance in a circuit. So resistance is defined in terms of ohms, which you can see on top of the voltage and ampere. So this is a passage where your resistance as a component, which has the unit in terms of ohms, restrict the flow of current when it is flowing, and voltage the pressure on the flow of current which push it towards the direction in which it is flowing, but the function of the resistor is to restrict the flow of current. That is the meaning we have to understand from the given picture. So ampere is current which is flowing in a direction due to the potential difference or pressure created by the voltage. That is, voltage is pushing the current in a particular direction, and the function of resistance is to block or reduce the flow of current in its path. So the ohms represent the resistance, amps represent the flow of current, and voltage is the potential difference. All three together are the basic unit of the Ohm's law, that is V equal to IR. So these are the types of resistor what we practically have in the electric circuits. The first one is a carbon composite resistor, the second is carbon film resistor, and third is metal film resistor. So these are the various types. We will go through one by one in the forthcoming topics in the unit. And this resistor is represented through a symbol of a small or equal triangles followed by a continuous line as a symbol. So this symbol, whenever you go through in a circuit, it means that it is a resistor. So here each resistor will hold a value in it. So we can classify resistor based on the values. So the broad classification goes like this. we have two broad classification of resistor. One is fixed resistor, another one is a variable resistor. So both will have the values and both will function according to the value. So how we have to identify the value of resistor is based on the color code what it has on it. So what you see on the slide is a 3-band resistor. It has 3 color codes, and the last one or the last color represent the tolerance. So the first digit, second digit and the third digit is called a multiplier, and the first 2 digits got values with respect to the color. You can see each row is represented with the color. The first row represents black, second is brown, third is red, and fourth color is orange. So when I say fourth color, we start from the number 0, so it goes like this. So first we can have the color black for 0. The number, if the line is 0, we have to take that particular color as the value 0. So here we have 4 colors in the resistor. The first one is yellow, the second color is violet, third color is red. So it goes like this. The yellow stands for number 4. So first value is taken as 4. The second value is taken as 6 because of the violet color or the blue color. 6 is taken. So 4, 6, and third is a multiplier. So we have to multiply 446 into 100. So totally we get 4600 as the total. So since the third color is red, we have to multiply that 100 with 46. So totally it is 4600. So the value of resistor is 4.6 kilo ohms or 4600 ohms. The last represent a tolerance, that is gold in color. So it represent a tolerance of 5%. So for example, if 1 is the value and or if 100 is the value of the resistor, we can have, if and the tolerance is 5, the resistor may function in the band of 95 to the range of 105 ohms. So this is the meaning of a tolerance. So there is a level or the range in which the resistor is functioning. And I hope this color band would help you to understand how the coding of resistor is being used. So following this, we have resistors connected in one particular fashion, or this type of connection what you see on the screen is called resistors in series. So when you go to solve a problem or when you go to analyze a circuit, so we have to reduce the number of components as much as possible in order to have a good or a method of approach to solve the problem. So here we have R1 to R5, 5 resistors which are connected in series. So we have to convert this resistors into an equivalent resistors by adding up all the values or summing up all the values only if they are connected in series. So R equivalent is the equivalent resistor of all the 5 values when it is being summed up. So this is how we have to convert the resistors which are all connected in series into a single equivalent resistors. And if a circuit got resistors connected in parallel fashion, that is what arrangement you see on the screen, and if you want to convert that parallel resistors into equivalent resistors, you have a different formula for that. That is R equivalent is equal to 1 to the ratio of 1 by R1 till 1 by Rn. So here it is Rn is R5. So we have limited to the R5. If you have more number of resistors, or if you have less, when it stops with R3, you have to stop the Rn value with the last value of the resistors when it is connected in parallel. So in this particular session, we have discussed about what is Ohm's law, what is the design thinking approach of solving a problem, and we have learnt about how the value of resistor is fixed with respect to the band values or the colors quoted on the resistor. We have discussed about the types of resistor, and we have discussed about what is a series connections of resistors and how it has to be converted into a single equivalent resistor. And last or finally, we have discussed about how resistors connected in parallel has to be converted into a single equivalent resistor, and we have discussed about the formulas of both series and parallel connection for converting or finding out the equivalent resistors. So I hope this session gave you a small idea of what is Ohm's law and how the resistor is mentioned or represented in the circuit, and converting series and parallel resistors to equivalent of its resistance. Thank you for watching.